Welcome back again, students. We have covered this entire unit 2 in the class itself. This is a brief presentation. Again, this is a brief presentation for you to for helping you to remind those concepts I took in the classes. Those were detailed, but these are very brief. So again, we have seen all these things, but I am going to focus more on the important points or a basic concepts, foundational concepts for you to refresh the memory when during your examination point of view. So the unit 2 of software engineering and artificial intelligence is going to cover the scheduling and resource management. The scheduling is like using a algorithmic way of allocating resources. The resource can be a processor, the resource can be any service, the resource can be any devices like a storage devices or a CD, DVD drivers, etc. But what the resource we are going to use here? Basically, we are going to schedule the containers. What package needs to be installed inside the containers? What are all the need for those containers? How many containers are needed? How many containers has to be maintained? How many different containers with the different environments with the different packages is going to be managed? And when any upgrade comes in, how it is going to be installed or deployed in each container, how the each containers are deployed inside the system, or how the container image is going to put into the containers, how it can be automated. So for these things we are going to see Ansible, Kubernetes, Kubeflow and Slurm as the examples. Okay, so the containers need to be managed. How we can automate this management process? So the orchestration tools, you know, the conductors of the music, the orchestra, right? There will be a conductor who will gesture his hands for each and every section to play some notes in their instruments, in their music instruments. The same way, there is going to be a conductor. That conductor is going to maintain or organize or automate how each container is going to react or act during the entire process, and this organization or this orchestration can be automated. So why these orchestration tools are needed? So when we have to going to work with only one container, it is easy for a human being to, it is easy for a developer to maintain that one container. What if we have to deal with thousands of containers? At least it's hundreds of containers. Every time you cannot repeat the same task that you did for one container for other 99 containers. So we can automate this process whenever you doing or upgrading or you do some tweaks inside a container. You can write a script for it, whatever the tweaks you've done with that one container, and you can adapt that script to other 99 containers. In this case, not other 99 developers has to follow the script manually. This can be automated. So why these things are needed? As I said, in the cloud or high performance computing environment or in AI networks, we will be handling or dealing with a multiple number of containers, let's say hundreds and thousands of containers. So this cannot be done manually with efficiently. So we are going to automate with the help of orchestration tools. So here we are going to focus on Ansible, Kubernetes, which is also called as K8s, and Kubeflow, Slurm. So we already covered this, why scheduling and orchestration is needed. to efficiently utilize the resource and automate the deployment and execution and management of the containers and resource. And for the purpose of scalability, you can immediately increase the scalability without any human intervention when the surge for the requirement of the particular resources needed. Whenever a resource is needed immediately, those resources can be allocated to a particular service, or when it is not needed, it can be turned off, or it can be handed to other services that requires it. So fourth, supports and distributed, and it supports the distributed systems. Let's assume if we are not running all the containers in one data center. The data center may be spread across a nation or across the world. These data centers can be remotely managed. For those things also we need orchestration tools. So what a scheduler does: orchestrator orchestrates, scheduler decides when and where a jobs run, and the scheduler allocates memory, processor and GPUs for a particular process. The process may be running a container, or whatever the software is running inside the container. So you can have multiple OS. I mean, for example, one OS in one container and another OS in another container, or you can cluster them as a single service, or you can give it as a cloud, as a pay as you go service. One of the example is your Google Drive. Multiple containers runs behind the Google Drive, and the Google Drive can be shared as a single cloud service where you can access. When the requirement surges immediately, the orchestration and scheduler tool allocates the resources immediately and automatically. That means it is automated. So fundamentals of scheduling. So definition: the process of deciding which task or a process should occupy a resource. In other words, when and where a task runs. When means at what time, from after which task, etc. Where means on what resource, what is the resource ID, what kind of resource, those things. So core objectives: you can maximize the utilization and you can minimize the response time, because if a human has to intervene these things and a human has to do it manually, it is definitely going to be not seamless, right, in the user point of view. And fairness. So fairness is where one container is running in a 85% utilization and another container is sleeping. So, or maybe the another container is running to its fullest, like 100%, and it is bottlenecking, then that is unfair. So what we can do is, whatever the container is which has a bottleneck issues, those processes can be allocated to the containers which is right now free or running in a minimal load. So long-term, the levels of schedulers: long-term schedulers, mid-term or middle-term schedulers, and short-term schedulers. Mostly the short-term schedulers are CPU schedulers, and long-term schedulers as a full job scheduler. A job contains multiple tasks. A CPU can run one task at one single time at a time. Okay. So key scheduling algorithms, you have seen this already in the operating system course: round robin, SJF, shortest job first, priority scheduling, multi-level feedback or a feedback scheduling, feedback queues, etc. So the same scheduling for a single system can be extended to distributed systems. So when it comes to the distributed system, the scheduler solves or addresses few more issues. Few of them are load balancing and transfer policies. When one particular environment is fully loaded, how that load can be transferred to other environment. So those kind of things, when it has to happen, when it should not happen, those things are called transfer policies. And sender initiated, receiver initiated is some things like this. Okay, sender initiated, it says one particular cluster is saying, hey, I'm full, is anyone free to take my load? That is a sender initiated. Receiver initiated is a cluster saying, hey, I'm just free, if anyone is having a bigger load or a huge load, you can share it with me. That is receiver initiated. So orchestrations already. Orchestration is a automating deployment. It's a process of automating deployment and management of services, and the issue it addresses is handling scaling, networking, and failure. For example, cloud is a fail-safe environment where if one hardware fails, it will automatically allocate a free hardware and starts to run from that. The user never sees what's happening behind the cloud. For the user point of view, the cloud looks like a single hardware, but behind it there can be multiple hardwares running to simulate a single cloud. So all these things we define: CI/CD pipeline, container orchestration, DevOps workflow. All those things we have already took in class. You can use those things. So four orchestration tools or automation tools we have covered in the class. So let's see something brief about it. First thing is Ansible. Ansible runs with the YAML playbooks. YAML is just a script that can be read by orchestration tools, and those tools is going to follow that script to maintain their containers or clusters. So Kubernetes, which is also called K8, and for large scale protection, and there can be other environments like high performance horizontal pod auto scaling methods that can help Kubernetes to scale seamlessly. The same container orchestration can handle Dockers. When multiple Docker container forms a cluster, that is called a Docker swarm. And other things which is need not to be covered. So after Ansible, we are going to focus on Kubernetes. So Kubernetes key features is it can roll out updates, and if any error is found, it can roll back them automatically with a single script, with the execution of a single script. So it can handle Kubernetes can handle the containers effectively and manage it effectively with the automated scripts. So third one is Docker Swarm, which I covered. So a clustering of Docker containers is called Docker Swarm. So Ansible is for the main purpose of Ansible is for automating a Linux environment. Okay, you have to understand the difference. Linux is not a virtualized machine, or it is not a container based, or it is not anything. When we have multiple servers running with a single type of a Linux OS, whatever you done with a one server, for example, this particular server A is running with a Red Hat OS, whatever you followed steps to do some changes in that operating system, that can be converted into a script, and then the script can be applied to other servers that is similar to the server A with the Red Hat operating system. So this can be automated with the help of Ansible workflows. So Ansible is mainly for Linux based things, and Ansible is also using a playbook which is written in a language called YAML, it's called yet another markup language. So these are the points you have to remember. So let's switch to, and for Ansible the scripts can be written in a Python, and it uses SSH. So SSH is a secure protocol that can connect to multiple servers to update the sources in that servers, and it is based on push architecture. Because it is not a request based, when something has to happen, it needs to happen from the command center, right? So when the command center pushes something as a script, it goes to that each server and it runs there, or whatever the steps need to be executed to upgrade the particular server can be run from, or can be controlled from, a single command center, which is another Linux OS which runs the Ansible. Okay, so Ansible use cases are already covered in the class. So we skip to Kubernetes. So what is Kubernetes? Kubernetes again, so Ansible is for Linux, then Kubernetes is for containers. The containers can be similar to Docker. So Docker, Kubernetes both focuses on microservices, but assume that those are two different products rather than the two different approach. So the same way the containers, the Kubernetes is used here. So the difference between the container and the Kubernetes and Docker is fully focused on the development, where Kubernetes is fully focused on the deployment and managing the services in a real time. So Kubernetes is not going to help more in your development side, right? So that is the difference you have to remember. So, and Kubernetes, all things can be automated with the same kind of a script. It can self-heal, it can balance the load between the containers, it can manage the traffic between the data passing through the containers, across the containers, and it ensures the consistency across the clouds. So for example, if you're running a program A in a container A, it is going to give the one output, and if you try to run the same program in a container B, right, it has to give the same output. So that is how the consistency can be ensured. So automated rollbacks and so what does Kubernetes do? So all these things we have already covered. The important points you have to remember is about the configuration. So how it can be configured? It can be configured with the help of secret keys, which is not like a password, but like a password. Only difference is a password can be authenticated or authorized with the help of a matching with the username, where API keys are a single element which acts as an identification number and also acts as a password. So K8 depends on API keys, which is called secrets, under configuration mappings. So this is an architecture of a Kubernetes and a cluster of containers. Here the containers runs inside a pod, and multiple pod makes a node. So whenever you can replace any container inside a pod. If you want to increase the number of containers, then you have to create a new pod where you can clone a new container. Can you clone a pod? That is a question for all of you to come up with an answer with a little bit research. So how does Kubernetes infrastructure work? So we covered this already in the class. The important points you have to remember is pods, node agents, and nodes. It comes like this: a container lives inside a pod, multiple pods forms a node. The node is managed by a node agent. All these node agents are controlled or managed by Kubernetes. So this is how it works. So this is a Kubernetes cluster. So we have already seen this architecture. The only extra thing here is you have to see how the Kubernetes cluster works along with the multiple node environments. So this Kubernetes cluster contains the tools to scheduling, managing whatever the task need to manage all these Kubernetes parts that can be held in this Kubernetes cluster. So we have seen this difference. I have already covered this difference, Kubernetes versus Docker. I will be sharing this PDF along other resources with you, so you can refer this PDF later on. So again, benefits of Kubernetes, you can see there is nothing different in Kubernetes as long as you understand the difference between Docker and Kubernetes, and if you understand and the difference between Kubernetes and Ansible, that is more than enough. So let's jump directly to the next thing is called Slurm. Again, it's like an Ansible. It is focusing more on the Linux utility side, Linux environment side, or Linux OSs. So the Slurm stands for Simple Linux Utility for Resource Management, which is a job scheduler. So unlike Kubernetes, Slurm is going to focus more on the automation side of executing a script to manage multiple resources in the Linux environment. It is an outdated concept right now. Most of the companies or high trend services have already moved to Kubernetes, but for sake of understanding the schedulers, we are going to cover the Slurm, and we are going to implement Slurm in our lab exercises. So like Kubernetes, we have seen this concept called pod, containers, etc. Right? Here we are not going to focus more on the containers, just we are going to assume that is Linux is a single machine, and in that machine we are going to allocate jobs. A job is nothing but a group of commands or a group of tasks need to be performed in a certain orders. So that's it for the Slurm. I am not going to focus more on the Slurm because it has to do with more with the lab experiment. So Slurm has few sets of commands that can be used to automate the certain management task inside Linux. So we have I have already shared the list of commands and what it is for. This is a PPT. All these things has been covered in our lab manual. You can go through our lab manual for a further explanations. Okay. So these are the few commands. This is not the set of commands only these are not only the commands. What to say? There are other commands also, but I have picked major commands that used in Slurm, so we can go through these things. So running, batching, allocating, queuing, cancelling a job, all these things can be. These are the main commands you have to remember for your lab experiment, and that's it. So we have finished with our unit 2. We can go for unit 3 after our lab. So next week come with the lab exercises, prepared for the lab exercises. Thank you.